In this video, we're going to be proving the derivative for the inverse of cosine function, which is equal to negative 1 over the square root of 1 minus x squared. For starters, we're going to assume the inverse of cosine x to be equal to y. And since we have this assumption, we can apply the definition to get cosine of y is equal to x. And we know that the definition for the cosine function within a right triangle is equal to the adjacent side relative to angle theta divided by the hypotenuse of the right triangle. So if I construct a right triangle as such, and I assume this angle to be y, the side adjacent to y will be x, and the side of the hypotenuse of this right triangle will be 1. Hence, the side opposite to angle y will be the square root of 1 minus x squared. This comes straight off the Pythagorean theorem, which states that a squared plus b squared is equal to c squared, a and b being two legs of the right triangle, c being the hypotenuse. Therefore, if we want to find any leg, such as a, it will be equal to the square root of the hypotenuse of the right triangle squared minus one of the other sides of the right triangle squared, hence proving that our side opposite to y will be the square root of 1 minus x squared. And now what we can do is take the derivative on both sides of the equation cosine of y is equal to x to obtain negative sine y times y prime is equal to 1. To rearrange this equation, we get y prime is equal to 1 over negative sine of y, which is also equal to the derivative for the inverse of cosine function. And the reason why for this is because we previously assumed the inverse of cosine x is equal to y. Therefore, if we take the derivative on both sides, y prime will be equal to the derivative of the inverse of cosine x, hence making this equation true. We can apply the definition of the sine function within a right triangle as, if I write it here, that the sine of any angle of theta will be equal to the opposite side relative to angle theta divided by the hypotenuse of the right triangle. Therefore, sine of y will be equal to negative the opposite side relative to y will be the square root of 1 minus x squared divided by 1, which I'm going to exclude. Hence, proving that the derivative for the inverse of cosine function is equal to the negative of 1 over the square root of 1 minus x squared through a right triangle.